Hello and welcome to Grace tutorial. In this video lecture, we will be discussing about the methods of the preparation of the aliphatic amines. So the first method that I have is by reduction. So in this reduction that we follow the various processes. Let us go for A, that is by using tin and HCl or HCl. Suppose I have the nitroalkane RNO2. So when this nitroalkane gets reduced, that means addition of hydrogen. So what is reduction? Addition of hydrogen or removal of oxygen, right? So when this nitroalkane gets reduced in the presence of SnCl2, stannous chloride, or HCl, then amine is obtained. Nitroalkane and this is amine. So what is the specific example of this? Let me write the specific example. If you will place here CH3 or CH3CH2NO2, then 6H SnCl2 or HCl. Look at here, I have taken the nitroethane. So when this nitroethane gets reduced, then what happens? CH3 CH2 NH2. So look at here, nitroethane has been taken. That means this is ethyl, and this nitro group is attached to the ethyl group. That's why it is nitroethane. And what happened here? This nitro group will be eliminated and the amine group will be added here. As a result, the CH3CH2NH2, that is ethanamine. Ethanamine is obtained. So this is the first reduction of the methods of the preparation of amines by using the tin or HCl. You can write by using tin or HCl. Similarly, the reduction also can be followed by the catalytic reduction. Well, if you look at the catalytic reduction, use the catalyst nickel or palladium. You can use the catalyst anywhere like that. Suppose I have nitroalkane itself, and when this nitroalkane gets reduced in the presence of palladium or nickel catalyst, then what happens? Then amine gets result plus 2 water. So what is the specific example for this? The specific example is that this is nitroalkane and it gets reduced to form amine along with the water. But what is the agent I have taken? That palladium or nickel catalyst. So this is a catalytic reduction. So let's take this specific example, that is CH3NO2 plus 3H2 gives rise to palladium or nickel. So what is obtained? CH3NH2, that is 2 water. So the main product here which is obtained is that methylamine. And this is nitromethane. So let me make you clear the first two methods of the preparation of the amine using the reduction method. These two reactions are the reduction reactions. That means reduction methods. By the reduction methods, the amines are obtained. But the first reduction has been taken place using the tin or HCl. The second reduction has been taken place by a catalyst, that means the platinum and the palladium or the nickel. Using the catalyst, the reduction has been taken place and finally the amines are obtained. So what you need to understand here, how can we prepare the amines using the reduction? So how the amines, how the nitroalkanes, when the nitroalkanes gets reduced in the presence of the catalysts or in the presence of the nitroparaffins, like tin or HCl, then what happens? What products are obtained? So that's what we need to understand. Well, let me tell you one more reduction, that is the reduction using the lithium aluminum hydride. Well, if you look at the reductions using lithium aluminum hydride, then you see, suppose I have RNO2, that is nitroalkane. And when this nitroalkane gets reduced, but here the reducing agent is something different, that is lithium aluminum hydride, then what happens here? Amine is obtained with the 2 water molecules. All the reactions are almost same, but the difference is that we need to use the different catalysts, that's it. So here this is nitroalkane, but here it has amine. So what is the specific example? Let's write CH3, CH2, NO2. So what's the name of this compound? Nitroethane. So when this nitroethane gets reduced in the presence of lithium aluminum hydride, then CH3, CH2, NH2 plus 2 water. That means ethanamine. Ethanamine is formed. So this is all about the first reaction, that is by reduction. Now move on to another from nitriles. That's all about the reduction by paraffins. But this is also the reduction from nitrile. Suppose I have taken RCN, alkyl cyanide. When this alkyl cyanide gets reduced in the presence of the nickel, or you also can put the sodium or alcohol, something like that, then what happens here? Then RCH2, NH2, amine gets result. This is alkyl cyanide, or we can say nitriles. So what is the specific example for this? The example is that suppose I have CH3, you also can write sodium or alcohol, CH3, CH2, NH2 plus water. So this is actually the main product that here it is obtained. So we have taken methyl cyanide. Methyl cyanide. When it gets reduced in the presence of the sodium or alcohol, then what happens here? Ethylamine. Ethylamine, or we can say ethanamine, gets obtained. So this is what the second method of the preparation, that is from nitriles. So far we have discussed the first method of the preparation, that is the reduction by using the nitroparaffins, using the different methods like using the different catalysts like lithium aluminum hydride, using tin or HCl or platinum, palladium or nickel, something like that. But the second method is also a reduction, but this reduction is something different, that the alkyl cyanide, or we can say the nitrile, gets reduced in the presence of the nickel to form the amine. So I hope that if you would write all these methods and the names along with the reaction specific examples, so that it would be very much definitely helpful for the preparation of the examination point. So well, that's all about the second method of the preparation of amines. Now we'll move on to the third method of preparation of amines. So if we look at the reduction of isocyanates, well, you see, isocyanate means this is isocyanate. If you will write RCN, that is alkyl cyanide, but RNC, if you will make it reverse, then it is called isocyanide. So when this isocyanide gets reduced with hydrogen in the presence of lithium aluminum hydride, then what happens? Secondary amine is obtained. Secondary amine gets obtained. This is alkyl isocyanide. So let us write the specific example. Suppose I have CH3 and C plus 4H, lithium aluminum hydride. So this is methyl isocyanide. Methyl isocyanide. So when this methyl isocyanide gets reduced in the presence of lithium aluminum hydride, then I do get dimethylamine. Dimethylamine is obtained. So the methyl isocyanide gets reduced to form the dimethylamine. This is about the third one, that is by the reduction of isocyanates. Move on to the next one. Here also reduction, but the reduction of amide. Reduction of amide. Suppose RCONH2. This is the formula for amide, right? So when this RCONH2 also gets reduced in the presence of lithium aluminum hydride, then what happens? RCH2NH2, then amine gets obtained. This is amide and here amine. So what is reduced to form which products, that we need to understand. The amide gets reduced in the presence of lithium aluminum hydride to form the amine. So a specific example is that CH3CONH2. This is acetamide. So when this acetamide reacts with, when this acetamide gets reduced in the presence of lithium aluminum hydride, then I do get ethyl amine. So this is what we need to understand from the fourth method of the preparation, that is by the reduction of amides. So we have done the reduction of isocyanates as well as we have done the reduction of amides. Well, this is all about some methods of the preparation of amines. Now we will move on to the another method of the preparation of aliphatic amines. If we look at the next method, that is fifth one, that is from oximes. So the oxime RCH double bond NOH, this is the oxime. This oxime also gets reduced in the presence of lithium aluminum hydride to form RCH2NH2, that is amine. So the example is that plus 4H, when it reacts with lithium aluminum hydride, then it gives CH3, CH2, NH2. This is actually ethyl amine. And this is oxime. That means the oximes also gets reduced in the presence of the lithium aluminum hydride or ether, in the presence of ether as well. Then we get amines. This is the fifth method. So all these things the methods that I have shown for you is about reduction. Now let's just move on to something different, that is solvolysis. So this reaction is what called Hofmann's ammonolysis. Hofmann's ammonolysis. Ammonolysis means it's nothing but addition of ammonia. So suppose I have from alkyl halide. From alkyl halide means I have C2H5Br. This is alkyl halide. That means ethyl bromide. When this ethyl bromide reacts with ammonia, then what does it give? C2H5NH2. C2H5NH2. Then this hydrogen reacts with HBr and hydrogen bromide gets obtained. So this is ethyl amine. So this ethyl amine C2H5NH2, this ethyl amine further reacts with C2H5Br. C2H5Br. So the product which is obtained when the ethyl amine again it reacts with ethyl bromide, then what happened? One more H will react with HBr and the HBr removed. So what is there? C2H5 and C2H5. That means diethyl amine is obtained. So if that diethyl amine C2H5 NH, if that diethyl amine again reacts with C2H5 Br, then what happens here? Then C2H5, now it becomes 3 because here C2H5 2 is there and here C2H5 1. So C2H5 2 whole 2 and C2H5, that is C2H5 whole 3. And this hydrogen it goes with bromine, that means this one HBr obtains. So this is triethyl amine. So this is what here it is obtained, triethyl amine. So when the triethyl amine C2H5N is again reacts with C2H5Br, then what happens here? C2H5, C2H5, this is N plus C2H5, this is whole 4 because here 3 is there and one more C2H5, right? N plus C2H5 whole 4, and this is what here at last bromine. This is what the tetraethyl amine is obtained. Well, this entire reaction is what called the Hofmann's ammonolysis. And this is one of the most important reactions that you need to understand. The step by step, the propagation takes place. The ethyl bromide reacts with ammonia to form the ethyl amine. Again, the ethyl amine reacts with the ethyl bromide to form the diethyl amine. Again, the diethyl amine reacts with the further it to forms the triethyl amine, and further it goes on like that. Well, this is all about the solvolysis, that is about the Hofmann's ammonolysis. Now we will move on to the another Now we'll move on to the another method of the preparation of aliphatic amines. So if we look at the second method, that is ammonolysis of alcohol. Suppose you have alcohol C2H5OH, ethyl alcohol. When this ethyl alcohol reacts with ammonia, so what happens here? C2H5NH2, C2H5NH2, that is ethylamine gets obtained, and this HOH, that is water, is removed from here, H2O. But this C2H5NH2 again reacts with ethyl alcohol, C2H5OH, and it gives C2H5 whole 2, this is NH, now water. Again this diethylamine, that is C2H5 whole 2 NH, reacts with C2H5 OH to give C2H5 whole 3 N plus water. This is triethylamine is obtained. So the propagation, it goes on like that, and this method is called the Sebastier method. This is about the ammonolysis of alcohol. Just like the ammonolysis of alkyl halide has been taken place, similarly the ammonolysis of alcohol also, it goes on like that, but just the alcohol group has been added, that's it, no more. Similarly, I have, what I will go for the next one is that this method is called Sebastier's method, that you need to remember. And the next one that I would like to highlight on the point is that Hofmann-bromamide reaction. Hofmann's bromamide degradation reaction. So if we look at Hofmann's bromamide degradation reaction, suppose you have RCONH2 amide. When this amide reacts with bromine and KOH, alkali, the potassium hydroxide, this reaction is very important, that you need to remember, because often it's coming in the examination. This is amide. So when this amide reacts with bromine and alkali, then amine is obtained along with potassium dichromate, the potassium carbonate, and potassium bromide and water. So we can give the specific examples. Let us write CH3CONH2. This is acetamide. So this acetamide reacts with bromine and 4 alkali to form CH3NH2, K2CO3, 2 KBr plus 2 water. Well, the most important thing is that the methylamine, what here it is obtained. So that's what we need to understand, how from acetamide, how the amine is obtained. So that's all about the Hofmann's bromamide degradation reaction. And this reaction is very important because it's often coming in the examination, that you need to remember. And the last one, the last method of the preparation of this aliphatic amines that we will discuss about. So if you look at this Gabriel thalamide, let us look this reaction very carefully. I have CO. When it reacts with KBr, potassium bromide, then this K reacts with this nitrogen. So here it happens now NK. When again if it reacts with ethyl bromide, then this KBr, it goes away like that, and this ethyl is obtained. If it again reacts with water, then what happens? But the main product we want is CH3, CH2, NH2. This is ethyl amine. Well, this is all the methods, and from here the Gabriel thalamide synthesis, that ethyl amine. So ethyl amine, or we can say ethanamine, is obtained in the following way. And there are many more methods of the Catuous methods, and any other methods are there. But what I have said, all those methods are very important methods, and this is very significant for the examination point. And I hope that you take a screenshot of all these things so that it will be helpful for preparing in the notes. Thank you very much for watching. If you would like to go for the next video, subscribe to our channel for to get the latest notification. Thank you.